It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. Imagine you've mapped out your entities, connected the relationships, resolved structural redundancies, and reached third normal form. At this stage, it is tempting to declare the logical design phase finished. The diagram looks polished and the structure makes sense. But watch what happens when we try to use it. If a user inputs a -500 for an age, or references a foreign key that doesn't exist, this pristine drawing does absolutely nothing to stop it. The bad data writes straight into the system. An entity relationship diagram is only a structural outline. It defines the shape of the data, but it is completely silent on operational boundaries, behavior, and security. Without these secondary layers of logic, an implementation built solely from a visual diagram is vulnerable to the same data errors we just simulated. This is why the primary objective for Week 6 is to step away from abstract modeling and build an unambiguous, developer-ready technical specification. We bridge the gap between drawing and database using two precise mechanisms, the data dictionary and explicit integrity constraints. We are still in the logical sign-off phase. We are rigorously defining the rules conceptually, which means no SQL code should be written yet. This detailed specification is the actual mechanism that protects the database from the injection errors we just saw. Logical sign-off is achieved through textual and tabular rigor. The diagram provides the map, but the specification provides the law. Take a standard one-to-many relationship, like the link between a department and an employee. First, we establish domain integrity. Every attribute requires explicitly defined boundaries, specifying, for example, that an age must be an integer greater than 16. Next is entity integrity. We guarantee absolute uniqueness by defining a primary key and detailing its exact behavior, specifying that it must be auto-incrementing and can never be null. Finally, we enforce referential integrity. We state the exact operational behavior of the foreign key. If a department is deleted, we explicitly decide whether to reassign those employees or cascade the deletion. The visual line connecting two boxes has no functional value until it is codified into these three pillars of constraint. We document these constraints in a data dictionary, the central metadata repository that translates plain English business rules into a structured technical format. A professional data dictionary requires specific columns: table name, attribute, data type, domain or allowed values, key type, and whether the field can accept a null value. Every single entity, attribute, and relationship on your ERD must have a corresponding detailed row mapped out in this grid. When it is time to build, developers work directly from this dictionary. The diagram is kept around only for high-level context. If a business rule isn't explicitly written into the data dictionary, it simply will not exist in the final database implementation. Beyond just the data structure, professional design requires anticipating exactly how the database will be queried in the real world. This requires indexing. An index speeds up data retrieval for the most common access patterns, allowing the system to jump straight to the correct row instead of performing a slow row-by-row table scan. For Week 06, you need to identify 3 to 5 index candidates based entirely on the specific business queries your project requires. Every proposed index requires a written justification. You must balance the benefit of faster read speeds against the performance cost of slower write speeds. Database performance must be architected intentionally right now. Retrofitting speed onto a poorly planned physical model later is highly inefficient. We also need to map out security architecture. An open database is a liability, so access must be restricted by design from the very beginning. We rely on the principle of least privilege. Users and applications receive only the absolute minimum permissions required to perform their specific business functions. To model these boundaries, sketch 2 to 3 distinct user roles, like a read-only analyst and a data entry clerk. Map these conceptual roles directly against the tables defined in your data dictionary to create a clear permission matrix. Data security is a foundational structural requirement defined by the database designer, not a patch applied by network administrators later. All of these elements come together to form your Assessment 1 evidence pack. This is a logically linked portfolio proving your design competence. The core requirement here is absolute traceability. A marker, or a future developer, must be able to follow a single thread of logic completely through your project. A plain English business role maps to an ERD relationship. That relationship maps to a data dictionary entry, which then maps to a specific security access role. Breaking this chain of traceability signals a flawed design. Rigorous, interconnected packaging is essential for a high-scoring submission. This document represents the final logical design sign-off checklist. We use this to run our last quality control gate before any implementation begins. Looking at this diagram, we see a common point of failure successfully resolved. The many-to-many relationship between author and book is properly transformed into the worked-on associative entity. Once the ERD is corrected, your normalization evidence is documented step by step, and the dictionary is locked. The logical design phase is officially closed. Your specification is now completely ready. Next week, the focus shifts to enforcing these rigorous rules physically using MySQL.